not particular mine, but someone's. And for example, this is a building presentation of some architectural project and also interior projects. It's also made by using CAD programs. And CAD programs stands for computer-aided design. So particularly today, we are going to talk about engineering part. So SolidWorks can help us make something like as simple as bolt and as complex as entire engine. And even can make some simulations on stress or any other type we might need. So it's actually not only CAD, but CAE. CAE stands for computer-aided engineering. It's a little bit more complicated, but let's not go that deep today. So SolidWorks, as I said, it's a CAD program. There's a lot of alternatives as AutoCAD's Fusion 360, like Blender, or even Google's SketchUp is also considered as CAD program, or Rhinoceros, and a lot of bunch of stuff. But why SolidWorks? SolidWorks is particularly designed to help engineers to make like drawings and specifics for manufacturing. So you not only model them and see around in virtual reality, but also can help like write a program for CNC machinery, or can like make drawings so every other engineer who's not familiar with 3D models can read and manufacture that part. SolidWorks is actually very easy to start. It has very user-friendly interface. You can like look it up, and it's almost like Paint, the default program in Windows. And also, one of the best part of SolidWorks is community, because its community is very large, and there's a bunch of tutorials on YouTube alone. So you can start anytime, anywhere, and there will be a lot of help from online guys. So before we continue, let's make some demonstrations of SolidWorks itself. So here's the program. And can someone please say example of some simple things that we can 3D model right now? Square. Oh. Oh, donut. Okay. So when you 3D model, especially in engineering, you first make a draft on paper, or in our case, in whiteboard. So how can we make a toroid or donut? So actually, we can just make a simple circle that we can rotate about one axis, which will give us the donut itself. So let's start. So there are actually, since it's a 3-dimensional program, like 3D modeling, there's a front plane, top plane, and right plane that you can start with. So let's begin with right plane and start sketching. So as you said, so our first step is drawing a circle. So we choose the tool for circle and make some circle, and we also can define its dimension. So right now it's in meters, and actual donut's diameter may be like 3 to 4 centimeters. So 0.04 should be good enough. And also we should prepare a center line. So let's make it here. It's not going to be in the model itself, but it will help us. So After that, we can make like a resolved boss base. It means that it just extrudes our circle around one axis. So we're choosing that tool. And after that, it automatically detects it, and you can just click it. And here it is, your donut, toroid, whatever you call it. Actually, we can make one more example for better understanding, a little bit more complex, maybe mag or something like that. Croissant. Okay, let's make it more technical. Pencil. Okay. So let's delete everything, and so let's delete sketch itself. So actually, pencil is also simple, I suppose, because you can just take. Okay, let's draw a simple pencil. How it's going to be? So it's like this cylinder with the conus at the end. That's gonna be pencil, or okay, what it should be? Octagonal. Oh, okay. Okay, we're going with default one. So let's make we're going to take top plane and make a sketch. And there's a tool for polygons. You can just type it and choose like angle, or in our case like 0. Yeah. Why we need it to apply? Top plane. So pencil, we as default take it as like standing pencil. So we take like top view, and by top view it's going to be octagonal. So we do, actually it's hexagon. So let's make it octagonal. Actually pencils are hexagons, I believe, but anyways. And also let's define its dimension. So if you have a pencil, one side may be like 3 millimeters, I believe. So we can just adjust it by document properties to millimeters for easy use, and change that part to millimeters. And in our case, okay. Oh, we are not in the sketch mode. And right now we are in sketch mode. Okay. So okay. So as I said, this CAD program is designed for engineers, and before you start making 3D model itself, you start by a simple sketch of one plane by which you can start model itself. So let's make that side like 3 millimeters. And after that, we can extrude the whole face to make like, what's the height of length of common pencil? 8. Okay, 8 centimeters, going to be 80 millimeters. Okay, and after that we make just so this part should be like pointy, conical, or in our case, we can just make it by using chamfer. It gives us so length of our chamfer cut and also the angle. So if you just imagine like this 90-degree, 90-degree place, chamfer is like cutting it on some angle, and it has two properties: one, this length, and this angle. So to make it more pointy, let's make our angle like 60, and we can just take that top part and okay, it's not giving us preview. Okay. So after selecting each edge, we will need to lower it. Okay, we have error because that was little. Okay. How we do that? Actually, we can just take that part as a new sketch plane. We can sketch the same octagonal shape. In our case, we can just offset entity. Okay. So we bring the sketch and make an offset by using that tool. And offset is going to be actually 0 millimeters because we want it to be the exact same figure. Why it's cancelled? Okay, now we have some figure, and we can extrude it, but by default it extrudes right upward without any angle, but we actually can add some degree of angle. So let's make it like 30. Okay, a little bit more pointier maybe, or less pointy. Okay. So that should be something like pencil. Huh? Let's go. Okay. So that was like a simple demonstration. That's very uncommon things to the model in that program actually, but anyways, okay. Now let's close it and do not save that. And let's start a new part. That's gonna be our next project for us. And let's continue with presentation itself, because further we're going to talk about shell echo marathon. Yeah. Okay. Okay. Oh? Oh, yeah, but okay, you're asking for too detailed model actually, and for cap, okay, let's make like top plane. Let's start with a sketch, as any model starts with a sketch. We can give so we should be able to do something relatable as a cap. And after we make like two figures, we can, by using trim entities, trim like this part and this part, which actually will merge our figures into one. And let's add some centerline that will help us. And after that, we can make again resolved both space. So axis of distribution. Oh, okay. It says that sketch is open, which means it's not closed by. They have some problems. Okay. So it's again in meters, and okay, let's make a cap something like that. So this one has a diameter of almost 1.5 centimeters. So it's going to be 0.15. Its height, that part, maybe something around 3 centimeters. It's not relevant actually, but okay. I want to overbold. Oh, and after that, we also should integrate radius of top part. So if our diameter here is 1.5, our radius should be half of that. So it's going to be 0.015 divided into 2. So we actually can enter some simple formulas. It detects it automatically. And that's what we have. And we apply a resolved both space. And this time it should be happening, I guess. Sketch is open. I don't get what it saying that it's open. Oh, okay. It actually do not love revolving around itself, so we should make it like half of that. So let's begin. Let's again open our sketch. View it directly. So that's the tool for viewing. So we can actually choose the right angle. Yeah, actually, it seems very unpleasant for your eyes because in 3D modeling world, there's not much of top down, right, left. There's no gravity, so it will like go around if I mess with mice wrong way. So let's divide that part into 2, and we take trim entities and trim the half of it. Afterwards, we resolve it on that axis, which gave us this form of some bullet-like form, but it's not shallow, which we can see. And there's actually another tool for that application. It's shell. We can just click it, choose the place we are going to start, and we give it thickness. So thickness of this place maybe like around 1 millimeter, which is 0.001 meter. which give us, oh, it's hollow. And as addition, we should make that part which clips to paper or something like that. For that, we can like take a front plane, start sketching another figure again, and let's add it something like here. So let's give it a thickness of maybe 2 millimeters. And also after we can add like this helping line for us, by which we actually, if we are not using any tool, we can just point the things. So like end point of that line, and like this line, and there's like relativity. So we can make it like vertical, so it's aligned vertically. We can choose second points and make it also align. But in our case, it's not showing that. Okay, that part is going to be the same, so 0.03. Okay. Now we extrude it to make it, give it some volume, and since it right in the center of cap, as you can see, it creates plane to one side of that. But we need it at the center. So actually, we can add second direction. So there's like a lot of function possibility, and the more you deep into that, there's it's going to be more complex. So let's make it half the thickness here and here. Okay, now we have that figure here. And after that, we can sketch on that inner plane and add some so for the sake of that being easier, we can choose that side and that part, and actually we should be able to okay, we can't hide it because it's not the entity. What we can do is actually let's make sketch from the other side, so it will be easier for us. So I'm choosing that side, so it's visible. I'm adding rectangle around here. Actually, you can just leave it as it is without the correct measurement, but it is actually going to be easier if you give something. Okay, it's too long. Make it like 10 times shorter. Oh, okay. Now we can extrude that part. Extrude meaning giving to the plane volume into one direction. So actually, it's going the wrong side. So there's like button by which you can just switch the direction. And if we make it too deep, like something like that, it's going to work well from the outside. But if you look at inside, so let's make it like there's a section view tool, which is another new tool. So you can just view its section. So what's not visible from the outside is visible right now. So actually we have problem right here. And to solve that, we can choose like different plane, so which will make it easier for us to sketch on. So something like that. After which we can again just sketch on that plane, which is like extra. And also by using offset and see using the by default 0, we can add that part, this lines, which gives us new figure, which we can simply, okay, it's extrusion, which is making it bigger, but we need to delete that. So we choose extrude cut. So instead of creation, it cuts. Yeah. So as I said, as I mentioned, it is better for you to make measurements for that part, which we defined. It's 4 millimeters. So we can just type 4 millimeters, and it's going to remove the exact part that's going to. So right now it's resolved, but in case of usability, this part is like very sharply. Don't you think so? So it may cut your hand or anything paper. So you can just make it feel it. So as I mentioned before, chamfer is just cut it at some angle, but actually fill it, going to make it round. So something like that. That's what we need. We need some smoothness, so we can just choose that tool. So radius, since its thickness was how many? 2 millimeters. Yeah, we can make its radius 1 millimeter, which is going to be ideal. You can just select top part, and it's going to create that thing. And we also can choose this plane, and also we can choose that plane, which is going to be extra. Okay, that edge and this edge. After applying, it makes it more smooth, but as you see, these two corners are like pointy. So we can, so on the left part, there's history of what we did. So last one was fillet. We can edit it. So by editing, we can actually just add the two edges that we missed initially. And voila, our cap is ready. Okay, let's move on with our presentation. So shell ecomarathon again. As I said, I participated in that competition. It's international competition when you create literally cars. There's like pilots inside. It's not very big. It's like 2 meters in length, a meter in width. And after creating that car, each team race it on circuit. So that's modelирование circuit, at which our Asian part was like in 2022 and 2023. So 2 years it was held at modelирование circuit. For a better understanding, that's the layout from top view. Actually, modelирование circuit located in Indonesia, and it's used for competitions like MotoGP and any other racing. So it was a very good experience for us. After making your car, and racing it at modelирование circuit, you race not for the position by time. It's not time attack. It's not a regular race. Our goal is to make our car as efficient as possible. So what it means, they give you half an hour for you to ride the circuit 3 times, and that's going to be around 12 kilometers. After that, they measure how many energy you consume. Yeah, if you're like in fuel type, how many liters of ethanol you used. If you're at electricity category, which were us, they measure how many kilowatts of energy you used for that, and after which they make like a ranking of from the most efficient to less efficient. We participated in first time. That was our team. That's part of our car. Actually, we didn't get any position in first one because we were eliminated because of our beloved driver's mistake. And our second try was in 2023 with the same car. We modified it to make it like more efficient, more lighter, and we got 12th place. Yeah, it may sound like not the first one through or third, but actually it's a very good result, because to get into final stage is the achievement by itself, but being 12 from 27 finalists is not bad either. So actually we got 187 kilowatts for 187 kilometers per kilowatt of energy. For the measurement, first place was 760 kilometers per kilowatt. So we're not as near as we could be, but we will be participated in this year and next year also, and we hope we will improve our results every time. So that's our car. As you can see, there's 2 wheels on the front and 1 on the back, rear side. There's like place for cabin for our pilot. But for today's hand-on experience with you, we will talk about our brakes. There's like 2 wheels, and we used bicycle brakes. In bicycles, you may be familiar that there's 1 handle, 1 brake for 1 wheel. So each wheel has its own brake. So for example, there's the handle, and there's the front wheel, and there's like a rear one, and on the handle you have like second brake. That's the simple connection that it gets in a regular bicycle, but in our case, regulations say that it should be 1 system for both front wheels. So actually that setup, if you like take it in our case, it's like, let's make it different color. So for example, so it's our car's front, 2 wheels, and if you make it like 2 handles, and we just connect them with some plate and make it like that, that's actually, as we experienced it first time, was the reason why we had troubles, because by regulations that counts as 2 different brake systems, but we should have 1. So there's the question, you need to connect this 2-1 and these 2 brakes with 1 system. So it implies that you should connect four cables into 1. Actually, we had hydraulic brakes, which indicates that we didn't use wire system, but hydraulic, like some liquid for brakes, and it should be like flowing into all four. So there was a task of connecting. So there's actually a market ready solution for that, but since we already were on Lombok and there was no shops who had that connector, we should have we needed to make it by ourselves. So that's what we are going to do with you. We are going to model that connector. So let's assume that we have some block of metal, and there's different ways to connect these cables. You can like connect two from both sides and two from this side. One from each side. Or actually, since we just need one system, but not two handles, we can make one from top, and it's going to be like T connector. And there's also another variant for 4-cable system. It's like this 2x2 parallel connection. So in case of first one, you make connection like this drawing, and in that one like cross. And there's also cross. It's very simple, but in that case, you make H connection, right? So since we are engineers, not 3D modelers, we should think about it by the viewpoint of manufacturing. So actually, there's only 2 correct solutions out of 4. Can anyone T and H, this one and this one, yeah? No, I was asking which where are not going to work. Yeah. Any guesses? Okay, actually, these 2, so it's short and force, are ones that are not going to work. Yeah, that's the right question. Because in hydraulic brakes, on handle, you have like this reservoir which moves. So it compresses the liquid. And if you leave only one brake, one handle for 2 brakes, it will lose the half of power for each brake, which is going to work, yes, but it's not going to work as it should be. So our brakes may not work when we need it. So that's one, this is eliminated. And H, since we are making that connector from the solid piece of metal, that connections are going to be drilled, right? And okay, you make like drilling for these inlets, and that canals are going to be very, very thin. And these 2 are possible. You can just drill it from one of the sides. But that part, if you drill from the side, you will leave like also drill here, which will end up by leaking all the fluids that we should preserve. Yeah, actually, we can like drill and afterwards like close that part, but it's too many steps for manufacturing. And so we have these 2 solutions, and since we are our goal is energy efficient, we need our car to be as light as possible. So which of these outlines uses the less material. How do you think? Okay, any other variants? So, okay, so everyone assumes that it's going to be first one, and after my question, you all switch to second one. Since there's going to be like connector bolts, there are like default measures. If we make that one, we make it like trim that side off. Yeah, it's going to be like slimmer, but the width is not it can't be compressed anymore. But by this layout, you can actually make that size smaller and make it like really close to each other. Okay, so let's try to make that part, and for the sake of our 3D model, let's also say that the connector part is going to be something like that. So that place is going for a screw bolt we are going to use. So there's going to be some bolt which will connect that, hold that. That one is going to be our inlet for our canal. And that one is going to be the canal for our liquids. So this part was like 2 millimeters in diameter. Actually, it's going to be represented as like that, such. And this part was 6 millimeters. And that part, we used M10 bolts, which represents as 10 millimeters in diameter. So let's switch to SolidWorks and create new part. Okay, it's okay. Yeah, and yeah, it's going to be weight less, which will increase our efficiency, as per se. So let's do it together. What's our first step going to be? Okay, we choose top plane then. Front plane. Oh, we're switching to front plane. Okay, why? Okay, let's make a sketch, right? So since it's made of block of metal, we can just start by making that block itself. So, okay, for making it easier, we change our documents parameters into millimeters, because all our measurements are in millimeters. We get into sketch 1 and give the width. It may be like 4 centimeters. And since it's symmetrical, we can make it a square. So it's going to be also 4 centimeters, which is 40 millimeters. And let's give it a thickness. Which tool we are going to use? So we should make a 3D object from that sketch. So we should like extrude, yeah. So that's the tool for it, extrusion. And let's make it like 2 centimeters. So that's the block of metal that we are going to start. And we should make that cuts for our bolt, canal, and everything else. So we start by sketching on one side. That's sketching, okay. So if we don't know where the center of that plane, we can just point it into that line, and it will show us center point, which will like align if we move very slowly. And second one is here, so it just helps me to find center line. After which we create that. Right. So our diameter is 10 millimeters. So, but by default, there is in parameters radius. So we should make it 5. After which we not extrude. Okay, it was a mistake. No one did see that. Okay, so extruded cut. I forgot to mention that part. So actually, that was 10 millimeters too. That one was 4 millimeters, and that's the rest of it to connect it. So we make a cut deep as 10 millimeters. And second cut going to be also circular right in there. And we're going to sketch it. So if you point into our circle, it will automatically give you center point. After which you can make second one, which is 6 millimeters. And its radius is going to be, okay, right. And its depth going to be 4, yeah. So we make it 4, okay. Okay, so that part is actually done. Since we do not have second hole prepared, we will not connect them with our 2 millimeter canal. And if you are not using any tool in that view, you can choose planes. So we choose all our cuts planes, and there's actually a tool for patterning. So we can choose like circular pattern, and to revolve it around like top plane. And it already showing us preview of our second cut, but we need total of 4. So there's the number. We're going to enter 4, but it is overlapping each other. So actually we have another parameter of angle, and since it's symmetrical around 360, we divide 360 into 4. And it's going to be like that. And if we accept that, it like duplicates all the holes. And we can preview that part. Okay. Now we connect them by, again, 2 millimeter hole. We use sketch and make it a circle of 2 millimeters. Not one, that one. Okay, I assigned a radius of 2, but our diameter is 2, so it's actually going to be 1 millimeter. And we use extruded cut. So extruded base and extruded cut is actually the most common tools you're going to use in that program. And all the time we gave this parameter some depth, but actually we can just use that arrow to make it any way and any depth just by default, like this kind. It's overkill, but it's going to work. So right now we have pass-through. And if you move into that view again, we can see that hole. And we can also duplicate that very easily by pointing that plane and making circular pattern again. And this time it's going to be like second one, and angle going to be 180. And it's going to be around that plane. Okay, 190 is too much because it just flips it. Let's give it 90. Okay, right now we have our connector, but there's the problem. Yeah, we know that there's going to be bolts and it should be threaded. So we need some threads. And for that, here's like tool like Hole Wizard, because it's going to help you. And it actually can make threads for you. You just choose it. Yeah. Prisba. So first of all, you choose the plane you're going to make that. Okay, so it's already previewing. So that's how it's going to be if you apply it. So that's actually type inch die or metric die. So much in Kazakhstan is by default, I believe, metric die. Okay, thinking. And size. So that sizing is too specific. I'm going to leave it as it is. Actually, we don't need it right now. And we're going to extrude that thread because, okay, let's explain that too. So when you have a thread on your bolt, it's something like that, right? And on the sides, you can see like this teeth. And by default, if it's M10 scale, so there's other side, it means that it's 10 millimeter of diameter from the outside of this teeth. So if we're going to make a thread on that plane, it should be like overlapping here. So by making it extruded one, so we're creating that thesis, it's going to work very well with our bolt. But if there's another option of cutting, okay, you may not see, but there's cut and extrude, two options. The cut one is going to be making it something like that. So it will leave gaps, and our bolt is not going to work with that hole. So that's why we extrude it. And our hole is now has threads. Okay, it's actually very simple to the model. I'm not going to make it for all 4 holes. And since we should have it as light as possible, I want to ask your suggestions on how we can trim it more. Oh, okay. Okay, there's 4 corners. So actually what we can do is we can sketch on that plane. and make like something like that, and let's give it a defined width, which is going to be maybe 13 millimeters. And since it's symmetrical, we also should extrude it also for 13 millimeters. Okay, now we have cut at one angle. What I should do to make it in all four of corners? Okay, as I said, we can just choose these two planes and make it as pattern and make it like this circular pattern. And if you choose it like that, make it 4 and make it like this. It already, okay, it's almost works, but as you can see, it have like some offset. Why is that? Because when we tap for that plane, it by default take its center point. And since we already cut that part, center point moved a little. So its center point is not actually our center point that we are looking for. That's why it's not going to work unless we make it like a circular pattern again. We can just make it around that one. It's going to be 180. Okay, now we have 2 of them, but not 4, yeah? So actually we can just repeat that part. Around another hole. Okay, now we have something more lighter. Is there any suggestion that we can do to make it smaller? More round, okay. But have you thought about that thickness from top and bottom part? Maybe we can trim that off too. Okay, let's start by that part. We can make this one and give it thickness of like 4, but actually there's a hole, and if we trim it right until there is going to be a gap of like 1 millimeter, which actually not going to help us because it will be our weak point. So that's why we trim it like only 3 millimeters. And after that, we make it second one. And going to make it also 3 millimeters. And right now, again, our beloved tool of extruded cut. And we just trim top and bottom. Okay. And what was your previous suggestion? Oh, previous one. Make it more round. Do you remember which tool we used for that? Okay, actually it's fillet. Yeah, I know it's very tiny words to read from that place. Okay, since that diameter of hole is 10 millimeters, and we want thickness of 2 millimeters from around it, the closest we can get is actually in radius like 10 plus 2 from each side is going to be 14, and half of 14 is 7. So we're going to make it a radius of 7, and we just choose that side. And it may seem easy, but actually it's very hard to point into that corners. Извиняюсь. Okay, after that routine work I done, we just click enter, and voila, that's our like final stage. You can look. So actually, what we could have done also is making this two closer as much as possible, but to leave 2 millimeters from that side, that's going to seem very hard to do. But actually, for it to be done, you can just get back into our history, our first sketch, which was our base. Let's make a measurement. So it's one dimension. Okay. I want to score. No. Okay. So it shows that that lens is actually 12 millimeters, and that diameter is 6 millimeters, right? So actually we can trim from 12 till arbitrary 9 millimeters. So actually we go back to our first sketch, which was our cube, and just make it smaller by 9 millimeters from each side. So it's going to be 31 millimeter in width and 31 millimeter in height, and that's more likely may lead us to it may create actually error if you do it the wrong way. So it's thinking, because after we reshaped our initial sketch, it's going to recalculate every step that it's already done. So that's why it's taking this long. And also my laptop is very old for that purposes. So let's wait a little bit longer. So let's cheer our laptop for it to work properly. Okay, so as you can see, there's error, but error in fillet. So our last step, so it's actually make it like that. Oh my. So if we just delete fillet, we end up having that figure, and it's very close. Oh, so there's the mistake that we did, but more particularly what I did. So our goal was to make from 12 millimeter gap 9 millimeter gap, which will take like 3 millimeters from each side, not 9. So we should redo our shape into 37 millimeters. Okay, okay. Now let's give it another few minutes for it to sync. Oh, okay. So now it's showing us that it's in that form, and that thickness went crazy small because we trimmed like 3 millimeters from. So it's going to be 1.5 millimeters from each side. So our cutoff corner should be actually less by 1.5 millimeters. So it's going to be like 13 minus 1.5. Okay. And after that, our extrude cut should be also less to 1.5 millimeters. So it's going to be again minus 1.5. And voila, it's again looking better. So last one is to offset, actually fillet it again. Actually, we can make it another way this time. So it's again 7 millimeters, but we can just click top one and the bottom. But that giving us preview that this corners is going to be filleted too, which is not going to help us, because if I just accept that, okay, it gives us this weird shape for our bolt, so it's not going to work. That's what you should consider when designing. So that's why we again did our last mistake. And let's make fillet again the right way. So we are choosing these corners and okay. So it's actually very delicate work to do. When you work on the more complex models, you're going to be sit here and be like, oh, okay, too much labor work for my accuracy by mice. Okay, that's the. It shows that I accidentally selected the edge, plane, not edge. So, and actually, we can also take into account that corners for it to. Oh. Okay. So that's our like finer, more beautiful way to do it. Okay. So first one was the simple connector from block of metal. It is easy to manufacture with the simple instruments that you have, but the fillet that we done makes it more complex to manufacture, because for doing that complex shapes, you need like 3-axis CNC machinery, which is like a robot that costs a lot of money. And if you do not have that access, you may not do that. but it also increases the cost for manufacturing. So always when you 3D model something to manufacture, you consider two aspects. It's how many money you willing to spend, and how acceptable your current model per se. So that was a simple example, relatively simple example, but actually that's one of the simplest models that you will do. And actually, if I was not talking, I might do it much faster. But during our 3D model of that model, particular one, we also gone through several steps of several designs. So you make like first prototype, you find the flows, and you do like second one, third one, and you define it until it's like in final form, which is acceptable for you. And also after we cut all the holes, when it was like just block of metal, you could call it a day, but we also consider it on how we can optimize it for our needs. In our case, it was weight reduction. So that's also one of the aspects of engineering, I would say. So after that, all beautiful 3D model, but what we end up doing was just block. Yeah, I manufactured it by myself, and I didn't have access for CNC machinery. That's why I thought, okay, block of ice is going to be okay, because just making it rounder will save us only a few grams, which can be like driver who drink less maybe. So thank you for your attention. That was like just a preview of what SolidWorks can do, and I hope it was interesting for the rest of us who are sitting still. So is there any questions? Any questions not only related for 3D modeling or SolidWorks?
У меня есть очень важный вопрос. Это по созданию машин. Вот смотрите, он рассказывал о том, как создаются машины, и потом они ездятся, ну, испытываются на соревнованиях. Делали ли вы данные прототипы у нас в Казахстане, и где вы испытывали их? Можно на русском.
Ладно, уговорили, да. Нет, на самом деле, вот эту конкретную машину, ну, я, как уже сказал, мы команда Назарбайского университета, и мы его делали в нашем университете, потому что у нас есть технопарк, это у нас отдельный цех, где студенты с разрешением могут условно использовать любые инструменты, которые там есть, ну, до какой-то степени. Потому что чем сложнее, чем опаснее инструменты, тем нам нужно будет быть под присмотром инженера или же полностью передать задачу инженеру, чтобы он нам это подготовил. И мы, в принципе, потратили на эту машину. Ну, это просто было создано в период пандемии, из-за чего это такой долгострой, и она собиралась 3 года, хотя можно было и быстрее. А тестировали его мы тоже, у нас в универе кампус достаточно большой, и у нас там были участки дороги, которые мы могли использовать для того, чтобы намотать круги, так сказать.
Ну, то есть место, где это протестировать, было прикольно. Да. У меня закончились вопросы, если у кого-то есть, ни у кого нет, хотя бы...
Вот вопрос. Такие более интересные вещи начались, да?
Не, вообще, простой вопрос. SolidWorks, он более требовательный, чем Blender или нет? Ну, он бесплатный или нет?
На самом деле SolidWorks, там вроде есть студенческая подписка, насколько я знаю. Если ты являешься студентом, ты можешь подать заявку, и они в основном его одобряют, и тебе дается уже студенческая версия. что почти ничем не отличается, потому что то, что мы делаем, это такие базовые вещи. Требовательный ли он, чем Blender? Нет, но да. Почему нет, но да? Это то, что, допустим, то, что мы сегодня сделали, это просто 3D-модель для того, чтобы мы это просто понимали и смогли это сделать сами, да? Из-за чего там не было никакого рендеринга. Ну, если мы... Типа,
вот еще насчет рендеринга хотел спросить, типа, он быстрее рендерит, чем Blender? Или как?
На самом деле они используют одну и ту же технологию. То есть, типа, это вот Cycles, IV вроде. То есть это разные методики, которые они оба используют, и, в принципе, под одинаковым железом они будут работать одинаково. Но мне кажется, SolidWorks будет быстрее, потому что он более проще, так сказать. Типа, но на нем тоже делают прям очень реалистичные модельки, но, опять-таки, тут уже момент в том, что Blender, он более для артистов, а SolidWorks, он более технический такой.
Спасибо за ответ.
Наверное, на этом хотела бы поблагодарить.
Да.